Hello viewers, welcome back to another section of my tutorial, and in this video we have an interesting concept to share. So this is differential equation tutorial, and in this tutorial we're going to tackle order and degree of differential equations. So I have several examples here I'm going to solve with you in this tutorial. Kindly stay tuned and also watch the video to the end. Please, if your first time attending this channel, kindly press the subscribe button and also turn on the notification button. So let's move straight to what you have today. So when you say order of a differential equation, it's simply the highest derivative that can be found in the equation. So if you have any differential equation, the highest derivative you can find is what we call the order of the derivative. Then when we say degree, degree is the power to which the highest derivative is raised. So there is a relationship between the order and degree. Order is the highest derivative and degree is the power to which that highest derivative is raised. So if the highest derivative is y prime prime or the cube y over dx, then the power to which that is raised is what we call the degree. Now with this explanation, I hope you can go straight to the questions and solve these problems. You can see I have put asterisks on this and this, meaning you have to take note of that very well. They are the tricky questions among them all, so you have to take note of them and you're going to solve it carefully. Kindly watch the video to the end and please don't forget to subscribe. So let's say the first question, the number one, we have the squared y over the x squared plus 3 multiplying the y over the x all squared plus 4y is equal to 0. So this is a differential equation as we have here, and you ask yourself what's the highest derivative we have here. You can see that it's the squared y, that is second derivative. So the highest derivative we have is going to be the squared y, and that is, so this number one solution. And write the solution. The first one, the order, then the degree. So the number one, I can see that the order is 2 because second derivative, you just write 2. Then what's the power to which this is raised? You can see that it's to the power 1. So you just write 1 as the degree, as simple like that. Let's see for the second question, number 2, write our solution here. So for the second question, we have the squared y over the x squared minus 2 dy over the x plus 3y equals 0. The highest derivative you can find is the squared y over the x squared, hence the order is 2. So you write 2 here as the order. Then let's see what's the power to which this is raised. It has no power, meaning it's 1. So therefore the degree is what? 1. So you just write 1 as we have nicely. Then let's see the third equation. In the third equation, we have the cube y over the x cube minus 3 multiplying the y over the x to the power 6 plus 2y is equal to x squared. Now this, you can see that the highest derivative we have in it is the cube y over the x cube, meaning the order is 3, as simple like that. So under the order you write number 3, the order is 3. Then let's see that of the degree. If the order is 3, what is the power to which the cube y over the x cube is raised? It has no power here, meaning the power is 1. So the degree is simply 1. Now let's go to the fourth question, which has an asterisk, meaning that it should be taken note of. So with the fourth question, I'm going to rewrite it here so that we solve to see it. Now, one thing to take note of is that for you to find the order and the degree of any differential equation, you should make sure that the differential equation is in the form of a polynomial. So for the order, it's simply the highest derivative, so there's no need for that. But for the degree, the differential equation should be in the form of a polynomial before we can go ahead to find the degree. So if you have in a polynomial, you don't have powers of fractions, so you have to eliminate every fraction in it before we can find the degree. So let's see that number 4. When I rewrite In number 4 again, I'm having the expression 1 plus the squared 1 plus the squared y over the x squared all to the power 3 out of 2 is equal to 9 multiplied by the expression the squared y over the x squared. Once I have this, the power is 3 out of 2. To eliminate this, you have to square each side. So when I square both sides, I'm going to get here times 2, then here 2 be squared. Therefore, these two cancel here, and I'll be left with 1 plus the squared y over the x squared all cube is equal to 9 multiplied by the squared y over the x squared all squared. So we can see that the highest derivative you have here is the squared y. Therefore, order is equal to 2. Then what's the highest power to be raised? You can see that if upon expanding this, you get cube of this expression. Therefore, degree is equal to 3. So without you simplifying this, you can't find the degree because it wouldn't be in a polynomial form. Let's proceed to the fifth question. It also has an asterisk, meaning you should be taking note of all. So y prime plus y prime prime all squared is equal to x plus y prime prime all squared. So once you have this, let me rewrite y prime plus y prime prime all squared is equal to open bracket x plus y prime prime all squared. So once I have this, let's see why I'm saying it's a special case. Now we can see that we have x plus y prime prime all squared there. So from here we can easily identify the order as the order being 2 because the highest derivative we have in the expression is 2. But what about the degree? We are having the power squared here and also this being in quadratic form. So let's expand everything before we conclude. This will give us y prime plus y prime prime squared to be equal to x squared plus 2x y prime prime plus y prime prime also squared. Now at this point we can see that this y prime prime and this y prime prime are the same, so they are going to cancel out. We'll be left with y prime is equal to x squared plus 2xy prime prime. What does that tell you? Now the highest derivative is y prime prime, meaning the order is 2. So for question 5 order, we've seen that order equals 2. But what is the degree? The power to which this is raised is 1. The 2 was cancelled out upon simplification. Therefore, the degree is 1. Degree equals 1. Take note of this. That's why I put asterisk there. Let's go to the sixth question. The sixth question, we have the cube y over the x cube minus the expression the y over the x all to the power half equals 0. This also is a special case with asterisks. So what it means that it's not in a polynomial form, and hence you have to simplify the fraction out there. So if I make it the cube y over the x cube to be equal to the expression then y over the x all to the power half, then I have to square both sides to eliminate this half. I'm going to have the cube y over the x cube to be equal to the y over the x, as simple like that. Hence my order is simply equal to 3 because the highest derivative is the cube and the degree, so here will be squared, sorry, and the degree is going to be equal to 2 nicely. Final question, question 7, also having an asterisk, meaning it's a special case, so take note of that, and that is very tricky. So we have y to be equal to 2 multiplied by the y over the x all squared plus 4x the x rather over the y. Take note of that, the x over the y, not the y over the x, meaning that we have to find the y over the x there. So here you can't conclude anything. So this is the same as y to be equal to 2 open bracket the y over the x all squared plus 4x multiplied by 1 over the y over the x. Meaning we have to multiply through by the y over the x, and we're going to get, let me make a y prime. Okay, the y over the x multiplied by y equals 2. The y over the x multiplying this, we already have the y over the x here, so to be the y over the x all cube plus 4x as we have here. So at this point we can easily see that the order is going to be 1 because the highest derivative is the y over the x, but the degree is going to be 3. So as we have gone through all this problem, I'm hopeful that any tricky question or any differential equation will be able to identify the order and the degree. Kindly watch the video well so that you understand it well. Thanks for watching, and don't forget to subscribe.